view it on there. In case they're not watching it live, they can still get the contents and all the information from this. Or if you guys want to go back and listen to something you did, there we go, the recording just started. You can feel free to do so when we post it to our YouTube channel, which is linked on our meetup group. But just for introductions, my name is Jake. I'm one of the co-organizers of the Desert Data Science User Group. I've been one of the co-organizers for going on like 1.5 years, maybe 2 years now. So welcome everybody who's either joining us for the first time or if you've been here before, welcome back. Today we have Pradeep, who is another one of our co-organizers, who is going to be presenting for us. So Pradeep, if you just want to give a little bit of an introduction for yourself and then jump right into it, I'm going to hand the floor over to you.
Sure. I'm just admitting more people as well. So Jacob, can you also admit people if they show on your screen?
I can. So yeah, you can just focus
okay.
on the presentation. I'll worry about making sure people get admitted.
Sweet. Awesome. So hello, everyone. I'm Pradeep Thiyyagura. I've been working with Neudesic for the past 2.5 years. And before that, I worked as a research analyst at Banner Alzheimer's Institute, primarily focused on trying to find the earliest biomarkers to detect Alzheimer's disease and prevent it before the disease goes to the advanced stages. And I used to work primarily with the MRI and PET images. And later on, as data science caught up, I learned some of the data science skills and then moved to a proper data science role. So that's a brief introduction about me. And then in this talk, I'm going to introduce Facebook Prophet. It's a tool that's primarily used to forecast time series data. So this is going to be the outline of the presentation. So time series data forecasting, what it is, why we need to do it. And then I'm going to introduce the tool, Prophet, which is developed at Facebook. And I'm going to give a brief demo of how Prophet works. And later on, we're going to do somewhat of a deeper dive into the inner workings of Prophet. And then we'll continue the demo with some advanced features. And later on, I will show a real world use case that we have, how we have used Prophet at one of our clients to solve one of their problems. And then I'll share some additional resources and references for you to go and explore more to get more grip on this topic. So many applications require forecasting, especially given the recent supply chain disruptions we hear in the news every day. We need accurate forecasts that are also updated regularly so that we have the most current forecasts so the business can plan around the forecasts. And also, if you take any data science course, like especially for the past like 1 or 2 years, most of them are focused on either image classification or natural language processing, and a lot of emphasis is given to time series forecasting. But what we have seen is like time series forecasting produces the most, is where most of the monetary value comes from, and it should be taken more seriously, and more people should like learn it. So Facebook realized about this gap, and they came up with this tool that makes anybody, irrespective of their background, with just a little bit of knowledge in Python, be able to produce relatively good forecasts without having to know a lot of background. So as an example, what we are seeing here are the number of events created on Facebook. It's not when the event date is, but when people tend to create events on Facebook. So we have that data from 2012 all the way till 2016. Just by looking at it, we can see that there is some sort of an yearly trend. We can see when it comes to December, the number of events being created are lower, whereas in summers they are like higher. And we can see that there are some outliers. At the same time, we can see that there is a wider band. So normally if you see a wider band in time series analysis, that means that there is a weekly trend. That means on Mondays, there are more events than on the weekends or something like that. Some sort of what this white interval tells us is that there is some sort of a weekly seasonality as well. And there can be missing data, and also there are outliers, as I just mentioned, and then so on. So these are the normal components of a time series data, and we need a tool to like model all this and learn from this from the previous information so that it can predict what's going to happen in the next 1 year or whatever date range that we would like to predict. Moving on. So before Prophet, the most popular tool that was available was Arima. And then you need to be somewhat of an expert to be able to like use Arima and get good results. So in order to explain the signal, there is an autoregressive part and a moving average part, and both of them require data to be stationary. That means there should not be any trend. So it's difficult to detrend the data. And also, in addition to that, we have to model the seasonal and holiday effects, and also the error term, because we need to error or the noise term, because we need to model that for the future predictions as well. So, and there are like all these parameters that need to be set in order to get a good forecast. And the amount of helpful information online is like very rare. So just visualizing the time series data also gives us like a lot of intuition. This is the same exact plot that I have shown before, but now we have color coded some of these dots based on the day of the week. Just by looking at it, I mentioned earlier that when you see a wider band, that means that there's a weekly trend. And by looking at this plot with color codes, you can tell that during the weekends, there are fewer events, whereas at the beginning of the week, there are more events being created, which are these yellow and green dots. So visualizing helps a lot to get more intuition about what the data is trying to tell. And then, so why Prophet? It's accurate and fast. It's fully automatic. Tunable forecast, analyst in the loop. So business users can input some of their domain knowledge into the model in order to get more accurate forecasts. And it's also available in R and Python. If you have preference towards either of these languages, you can use it. But for the purpose of this demonstration, we'll be using Python. So this is what you're going to get as an output of Prophet once you run the data that we just showed, the number of events that were created. And here is the date time event. And then we are trying to predict what's going to happen for the next 1 year, how many events are going to be created. So the black dots are exactly what we saw earlier. And then the blue line, although it looks like a band, it's actually a line. In the next, when I show you the demo, I like zoom it out, and this is actually a line. And the line is what Prophet's predictions are. And then the light blue line that you see here, that's the uncertainty interval. By default, it's set at 80%. That means that 80% of the data falls within these two, within the upper and lower uncertainty interval. And this is the most appealing plots. One of the most attractive aspects of Prophet when you're when you're showing the results to a business user is that it separates out each of these components. So the trend, weekly and yearly components are like separated out. So as we can see here, the overall trend like decreased in around 2015, and then it went up. And there is also a weekly trend, which we saw in the previous plot. During the beginning of the week, there are more events that are created, whereas towards the end of the week, many people are actually going to the events. So not a lot of events are created on the weekends, and maybe because they needed more time to promote. their event during the week so that people can attend them on the weekend. Similarly, around Christmas time, around the end of the year, there are fewer events that are created. Probably people are on vacation, or maybe they have created those events beforehand around Thanksgiving. So they're actually attending the events rather than creating new ones. And this is how the model is created. Oh, wait, before I show this, or do I have the, okay, yeah. So this is how the profit model works. This is this is what we're trying to predict. And we'll have a trend component, seasonality, holiday effects, and an error term. Basically, all the three components that I showed earlier, if you add them all together, along with an error term, you get the y hat. And to explain again what a trend is, trend is anything that does not change with periodic events. It grows over time, whereas seasonality is periodic. Seasonality captures the periodic changes. They can be weekly, yearly, daily even. Profit allows you to give your custom seasonalities as well. Let's say you want to monitor the quarterly data for if it's a financial company and they want to, since they run on quarterly basis, if you want to use that, Profit allows you to do that. And let's say you're trying to monitor something in astronomy and you want to follow the solar cycle, which is approximately 11 years, it allows you to do that as well. And holiday effects occurs potentially irregularly. These are the spikes that you see. Probably around like Christmas time or Thanksgiving time, the sales would go up, and all the public holidays and things like that. Those are cyclical for a given year, but within a year they occur at irregular intervals, and they can be more than one day as well, because Thanksgiving there are usually most places have a sale for more than 3 days. So you can have multiple days as a holiday event and then model it that way. And then here is the interesting, the differentiating thing from ARIMA to Profit is that Profit assumes the error term to be normally distributed. Whereas in ARIMA, a lot of focus is given to the error term, and they wanted to exactly model how the current the historical data is, so that they can do the same thing for future as well. And with that brief introduction, let's see how Profit works so that you have more intuition. So let me see if there are any. Yeah. So going through the demo, this is how you install Profit. I'm assuming that you're already familiar with Jupyter and Python just a little bit. This is how you install Profit. First, make sure that you have the GCC installed, and then use Conda to install Profit. And once that is done, you can load all the relevant packages. Most of it you're probably already familiar with, like pandas, matplotlib to generate some of the plots. And then I'm also using Plotly Express now, so that it allows us, gives us the ability to zoom in and out. That's quite useful when you're doing time series data. And also a lot of components. We'll be talking about each of these components in the next few cells. So as far as the data that we're going to use for today, it's a DV Bikes. It's a bike sharing program based in Chicago. And the data contains the number of bicycle rides taken daily from the beginning of 2004 till the end of 2018. So we have quite a few yearly data to explore and learn about. And if you do a DF info, this is what the data looks like. So there is a date time column, and Y is actually the number of bike shares on a given day. And we also have temperature. We'll look at temperature in the later cells, but for the very first model, our baseline model, we are only going to use the timestamp and Y, which is the number of rides on that day. And this is also the only pre-processing step that you need to do for Profit. The column names has to be DS and Y. If you change them, Profit will not like that. So make sure that you change the column names to DS and Y. And also DS should be converted to date time. So these are the only pre-processing things you need to do. And then visualizing the data. So these are the number of writes, like we mentioned before, and this is the date column. And since I did with Plotly, since I have a slider, I can slide, use a slider to zoom in and out and see how the data looks like over time. And also I can hover over a point and it displays the time and then the number of writes for that given date. Just looking at this, we know that there is some yearly trend, weekly trend, because the data is wider. So that means that that's sign that as weekly trend as well. And then we can also see that the overall usage goes down during the end of the year, probably in colder months when it's snowing in Chicago. It's not an ideal time to go for a nice bike ride. So probably the overall number of rides reduce during that time. And to build the baseline model, so we just initiate the model by calling Profit in empty parentheses and then model, and then we use model fit and then DF. DF is the data frame that we have here, which has only two columns, DS and then the Y column. And then we want to predict how the data is going to look like for the next 1 year. So periods are always given in days. So we want to see how the data is going to look like for the next 365 days. And then once we have that, we do forecast, model, predict future. And then we are plotting the results here. So clearly it takes less than 10 lines to be able to come up with this. And then here is what the predictions are going to be for the next 1 year. And the red line is our trend. And the black dots are our actual data points. And then the blue one is our predicted value. When I hover over here, you can see how the values change. And at the beginning of the talk, I told you that that's actually a line and not a band. So if I zoom in, you can like see that that is actually a line, not a band, because there are so many points, it looks like that. So you can see that it's actually a line that's trying to fit to the original data. And then we can also plot the individual components like before. So we saw that the overall trend, more people seems to be using bikes over time. The overall trend is upwards. And the yearly trend is lower towards the beginning and end of the year and higher during summers. And the way to understand these plots is that, so if you combine the trend, yearly and weekly components, you get your prediction, which is the y-hat. So for the yearly, the trend is for the yearly, the mean is at 0. We should understand that we should consider that the trend value, whatever is the trend value, is like here, and then it's plus or minus that trend value is what this is the deviation from the trend is what we are seeing in this yearly component. And similarly for weekly data as well, it's also very similar. So during the weekends, Sunday and Saturday, the usage is like less by negative 2000 from the trend. Whereas during the weekdays, the usage is more. So we can kind of infer that most people who use the bike share they're using it for work commute rather than for recreational commute. And then if you want to see how the values like actually look like, you can say forecast, and forecast will have like all the data, including our future prediction as well. So I'm just showing you a sample of 10 and showing you how it looks like. So this has the numerical values of the figures that I showed earlier. So we see the trend, and we have the y hat upper and lower, and the y will be, so this is the upper bound and the lower bound, which is the uncertainty interval, which is by default set at 80%. So you can be 80% certain that your prediction will definitely fall within these two bands. And if I scroll to my right, you will see the y hat, and there are these additive terms, and then the yearly upper and lower values as well. You don't worry too much about that, but if needed, if you want to use the weekly thing for any other plotting purposes, you can get that information from here. So with that really brief demo of how Profit works, we'll go back to the presentation and try to understand a little bit more. So any questions so far before I move on to the next slides? So I would take that as everybody's on page, and then we'll try to understand how Bayes' theorem works. So we need to understand just a little bit about Bayes' theorem in order to understand Profit inner workings a little bit better. So briefly, Bayes' theorem is the probability of an event based on the prior knowledge of conditions that might be related to the event. So based on the prior knowledge of the conditions that might be related to the event. And the mathematical formula is posterior probability is equal to maximum likelihood into prior probability divided by evidence. So to make it a lot simpler to understand, so we'll take an example. So let's say the probability that there is fire is 1%, probability of smoke is 10%, and probability of smoke given there is fire will be 90%. Let's say we have all these three values that are given to us. We can estimate what's the probability of smoke given there is, what's the probability of fire given there is smoke. So if you put these into this formula, we can estimate that that probability is going to be like 9%. So we're going to use the historical knowledge that we have and estimate what, and then estimate the probability of the posterior. So use the prior knowledge to understand the posterior probability. So in Bayesian curve fitting, this is what we'll use. So theta, let's say theta is like all the parameters of your model, and D is the data you have observed from the world. From the worldly experience, or the domain expert has some knowledge about the data. And then given the data we have seen, what are the highly probable parameters for our model? So that's what that's how we'll be estimating our parameters. And then if we multiply the prior and the likelihood and then divide it by the marginal likelihood, we'll get the probability distribution. So once you have the entire distribution, you know where your values are coming from. So most of the values for your parameter will come from that one distribution. And then if you show the distribution to a business user, and then if the values are like way off, then we can fine tune some of those things to input some of the domain expert's knowledge into the model to get more accurate results. And again, we are embedding the prior beliefs into the model, and we can regularize with sensible priors, and then we can introduce the uncertainty parameters into the model with the 80% uncertainty interval, so that we know that most of the we can have like certain amount of confidence in the model. And then the first component we spoke earlier as well is the G of T, which is the trend, and we can use L1 regularization, L1 regularized trend shifts to regularize the trend component. This is the most differentiating factor between ARIMA and here. You don't have to have stationary data, and the changes in the data are to be expected, and this is how we model the changes in the trend. And this is the mathematical expression of how that is done. So by default, Prophet chooses 25 points that are spaced at regular intervals. And then we assume that, so between two given points, we will try to calculate the slope. And if it changes significantly, then we'll consider that as a change point, and then remove all the insignificant points. And then we'll also, Prophet by default will also capture like around 75% of the data to put these 25 change points. And then there is also an offset parameter that needs to be there in order to make the line continuous. I will show a simulation so that you'll understand this term better. And K is initial growth. Initially, we'll assume that there is the growth K. And as we change from one change point to the next point, we'll estimate the change. And if it's significant, we'll keep that as change point and then go on to the next one. So there are two ways to model the trend. One is linear, and the next one is logistic. I'll also explain that in the next slide. Yeah, so here's how the logistical trend works. Basically, it's the S curve 1 by 1 plus e power x. So C of t expects the capacity of the system at any point of time. And similar to how we described the parameters earlier, K would be the initial growth, and this would be the growth changes, and this would be the offset to make the line continuous. One advantage of using a logistic trend is that you can cap your predictions. Let's say you're dealing with a model that cannot grow exponentially. Like there's a cap. You can set the upper bound and lower bound intervals. This will prevent the model from predicting values that are way off or physically impossible. Let's say a company has certain number of employees, like maybe 1,000. The model cannot predict like more than X. I mean, it all depends on the problem you're dealing with, but it lets you restrict your predictions to be within these intervals. So that's the advantage of using logistic trend. And the next component is the seasonality, wherein it allows us to model the weekly and yearly changes, and Prophet uses Fourier series to model those things. And here is briefly, if you have enough sine and cosine components, if you have enough number of n's, you can pretty much model any function. Is what Fourier is what this term tries to do. For example, for the yearly trend, there are 12 months. If you have, so Prophet has, so I'm explaining all these hyperparameters so that given a scenario that you have to go in and actually change something, you need to get it. But by default, Prophet chooses the ideal number of values that you need. So to capture yearly trend, yearly seasonality, the default is like 10. For monthly, like within a month, is 5. And to capture the weekly trend, the default is 3. If you are working with a use case that does not require your data to be this wavy, if the domain expert feels that this is too wavy and I should not be seeing this kind of trend, you can reduce this number further down so that you get a much flatter line. And if you have with n of 3, you can capture this kind of seasonality within a given week. And also the regular period is for a year is like 365.25, and for month it's 7, and week it's 7. And if you have custom seasonality, these are the numbers you can change. Like I was saying before, if you're trying to do quarterly, you can have maybe 2 for n, and then look at the components, and if that's not explaining your data well enough, you can increase or decrease it. And the next one is the holiday effects. As we discussed earlier, they occur on a potentially irregular schedules. They can also be greater than 1 day. and we use dummy variables to be able to model those holiday events. And Z of k is the change in the forecast for a given holiday. You can have multiple holidays as well. If your holidays are special events, so holidays doesn't mean that they have to be a government holiday. Like if you know of a really special promotion that happened, you can add that to your data frame, and Prophet will learn to use that as well. So I'll show you a simulation to explain all these things a little bit better. So this is a person who created M. Browns, forgot his name, but I'll share this link in the references, so you can like play with this as well. So these are the three main components that we have discussed so far: trend, seasonality, additional regressors, and then an error term, which we assume to be normally distributed. Like we discussed earlier as well. So K is the initial growth, and then A delta is the growth change, and this is the offset parameter. So let's start with the base growth. If you set the thing here, oh, let me refresh this. I opened it a while ago. It's probably frozen. Okay. Let's set the initial growth to here. So you can also increase it a little bit more. So that's our base growth. So it's constant at 0.07. And M is our offset. We'll give that certain value as well. And these deltas are our change points. There are 4 of them. I will increase it for 1. You can see that there's an increase. For the next one, I will decrease. Maybe after some time that the slope is lower. And then I'll use arbitrary values for the rest. So this is our growth, this is our offset, and this is a trend. You can see how it's going like upwards by capturing these upward and downward trends, downward shifts in the overall growth. And the next one is the seasonality. Here we are giving the parameters for A, B, and then I think there are two n's. So n is equal to 2 here. So we'll give some random parameters. This is for the sine component, and this is for the cosine. More components. You can play it. It's really fun to do. It really gives you an intuitive sense of how things work. Maybe I gave too much. It's out of the plot. Let me reduce them a little bit. You can see that by changing these parameters, how you're able to capture something like this. Maybe if you play with these parameters enough, you can capture more ups and downs in your curve. And if you combine them together, here is what the thing looks like. If I was a little if I was a little conservative with the parameters, maybe this would stay within this 100. You feel free to play with that. And going back to our presentation. Yeah, now that we have discovered more about the components, we'll do a deeper dive into our demo and understand how to use all these things in code. And here are the change points. So like I mentioned before, Prophet by default starts with 25 change points and then evaluates if there is an actual change in the trend. If it is significant, then it will actually change the curve. If it is not, it will let the curve be as it is. And you can like see the change points. And if you see that there is a line and it is not a change point, you can omit it, or you can provide your own change points as well. So if you know for sure that, for example, utility companies have moratoriums and things of that nature. If you know that a specific event that has happened during a certain interval, we can model it. And the next, as we try to improve the model by some of the things we learned in the previous few slides, let's say we want to improve the holidays. We want to add holidays and multiplicative seasonality to our model to make it slightly better. So by default, the seasonality mode is additive. From this plot, we can see that there is an upward trend, and as the trend increases, the bands are also increasing. That is a sign that we should use multiplicative trend instead of additive trend. If it is just going up in a linear fashion, but the variability is constant, then you would use additive trend. Since we see the other way, other kind of trend, we'll use multiplicative trend. And it is this simple to add country-specific holidays. Like let's say you're dealing with sales data or like any data related to US, you can specify the country name and it will model all the country-specific holidays to your model. And then the rest of the steps are the same. So you do the model fit, make a future data frame, and then predict that future data frame. And here is how the things are going to look like. So for the trend, it's going up. And then the holidays so this is the same data that we looked at before, the DV bike sharing data. So during holidays, the usage is actually 60% less than on a 60% less than the given trend. That gives us more certainty that in Chicago, DV bike users are mostly using it for work purposes and not for pleasure or travel, or like fun activities, which normally happens on the weekends and things like that, or major holidays. And also similarly, the yearly trend, not a lot of change, but I don't know if you have like noticed the y-axis has changed from actual values before in the case of additive trend to a percentage. So this is easier to interpret. So we can say that in January, the usage has dropped by almost 60% from the trend. That's an easier way for business users to like understand. And similarly, during the weekends, the ride shares drop by more than 20% compared from the trend. Any questions so far? I will take silence as no questions, and I'll keep going. And this is how you add additional regressors as well. At the beginning of when I'm showing the data frame, you can add in additional parameters, like say temperature can play an effect into your thing, or maybe there is an additional factor, external factor that you know for sure that has an effect on your data, your time series data, and you want to be able to like model that. The only thing you need to keep in mind when working with regressors is that you have to be able to have forecast the regressors as well into the future. When you're creating a future data frame, maybe weather data, you can get like 10 or 15-day forecasts. So you need to have, you have to have good forecasts for your regressors as well in order to get good forecasts in general. So keep that in mind when you're using regressors. Make sure that you can get accurate forecasts for those as well. So for this, in order to add regressors, we'll use the temperature and then the weather. So for weather, some of the entries were clear, cloudy, not clear, rain or snow, and these are the number of entries for each of them. And we'll convert them into dummy variables so that it's easier for the model to understand and like model those things. And here is how the temperature values are, and it's in Fahrenheit. And you can see, I mean, you expect the summers to be warmer and the winters to be colder. That's what we see here. It's not super surprising. But we'll let Prophet learn from this behavior as well, and we'll see what kind of effect temperature has on our variable, on our dependent variable. So here is the DS, and this is the Y value, temperature, and this is the data frame. We are going to, we have see, you have make a note that we also change the column names to DS and Y. You can leave the regressors any name you want, but the first two columns should be named appropriately as DS and Y. Otherwise, Prophet would not like it. And this is how you model add additional regressors. And also, I have changed the yearly seasonality to 4. At the beginning, I showed that by default, Prophet sets that value at like 10. You can make it lower so that the curve would be less wavy and overfit in future. You can like reduce that. So you can use this as a regularization parameter. And I'm adding the regressors like time, whether it's clear or not clear, rain or snow. And then I'm trying to take 2 weeks away from the fit and use those to predict those 2 weeks and predict the 2-week time period so that I can have these regressors for the future data frame as well. So once that is fit, I'm making the prediction and I'm plotting the different components. So you can see the trend component again, and this is a combination of all the regressors. So we have a bunch of them here, the temperature and all the 3 weather components. So this is a combination of all those regressors. In the next cell, we'll see how we can separate them out and look at them individually. And these things did not change much. We have already covered these things. And one thing to note is that the yearly seasonality is a lot smoother now. That's because of the change we made here, which is setting yearly seasonality to 4. And now the curve is less smoother, or like less wavy and more smoother. And then if you want to plot some of them as the coefficients, this is how that is done. So we have the temperature, and this is the mean value for temperature, which is like 53 degrees Fahrenheit. And the way to understand this table is that for every 1 degree increase in temperature, the ridership will go up by 1.2%. That's how we'll do it. I'll repeat it. For every 1 degree increase in temperature, the number of ride shares go up by 1.2%. And then coming to these other things, if the weather is clear, the ridership goes up by 10%, which makes intuitive sense. If there's clear weather out, the ridership goes up. And if it's not clear, the ridership goes down by 3%. And if there is rain or snow, the ridership goes down by 20%, which is understandable because if it's raining, nobody wants to take a risk and ride a bike in the rain. Although it's fun, but it's not recommended. Most people don't do that. So, and that's reflected in the data as well. And looking at some of those things in the form of plots. So this is how the temperature affects our dependent variables. And if it is clear, the usage obviously goes up. We can see that here. And if it's not clear, usage goes down, ridership goes down rather. And if it is rain or snow, the ridership goes down significantly, 20% lower than the normal trend. And cross-validation is really important for any machine learning problem. You cannot just go by what the model has trained on. You always have to like validate it to make sure that it's actually doing, it's not overfitting, it's actually learning from it, from the historical data. So for time series problems, you have to do it sequentially. You cannot just randomly pick certain points and divide into training test. And Prophet allows us to do it in a very easy to use manner. They have a function to do this, and you only need to. There are only 2 parameters that you need that are mandatory, and the rest you can figure out on your own. Or if you have a very special case, you can always go and set some of these parameters. So the 2 parameters that it requires as the model that you have created earlier and horizon. Horizon is the how far you want to predict in future. For example, you can learn from all this data and predict for the next 30 days. Is what, if you want to make your prediction for the next 30 days, that's what you should give here. And then the period is like, how often do you want to update the model? And you can define it by the cutoffs, or you can specify an interval here, like let's say 60 days. So the way to understand that would be, you learn the data till here, make a prediction during this interval, and then after 60 days, use that entire data from this point till this green line and make a prediction for another 30 days, and then so on and so forth. If it is confusing, we'll share the slides so that you can go back and look at this figure again to like get more intuitive sense. And the initial, you can set that, learn from maybe like 3 years of data and then start making predictions. You can set that as well, so that I think by default it will try to take 2 years, at least 2 years of data. If not, you can have more initial learning period and then make predictions. So once you do this, it will automatically do the cross-validation for you and gives you the results in the form of a data frame, which will look like this. And as you can see here from our settings, it made a 6-fold cross-validation, I would say. And then for each of those dates, wherever there is a cutoff, these values will be here. So there will be 30 predictions, and then for the next cutoff, there will be 30 more, and then for the next, there will be 30 more. So that's how this data frame will be. And once we have all that information, we can easily calculate performance metrics by calling this function and the data frame that we generated earlier. And this is how the various performance metrics. You can choose MSE, RMSE, MAP, make any of your favorite performance metrics. All of them will be here. And you can also plot them. I plotted MDAP so that you can like see how the predicted values deviated from the actual values. So that's in short how you can use Prophet and come up with predictions. If we go back to our presentation here. So analyst in the loop is the key, and that's what makes Prophet more fun to work with. So the workflow is usually goes like this. So you create a model, evaluate the model, surface the problems, and then visually inspect the model by using the different component plots, and then update the model, and the cycle continues until the analysts and the business users are like happy with the predictions. And I've covered how cross-validation is done in the demo. So I'll move on to, so for one of our clients, we have used Prophet to solve one of the problems. And here is how I'm stating the problem and how we approach the problem. So similar to how we all have like air-conditioned smart thermostats like Nest, there can also be smart electric water heaters. And we did some exploratory data analysis with very little data that we have, just to see what kind of information we can find from the electric water heater data. And we fit a model, an additive model here. You can see that the black dots are obviously the source data, and then the blue dots are our predictions. And then it's hard to see the certain intervals from this because there are a lot of data points. And the water heater data is collected from around roughly 50 users from the beginning of this year till summer, till very recently. And these are different trends. So in winter months, obviously, the water heater needs more energy to heat the water. So what we see here is the energy required to heat the water. So the overall trend, as summer months approach, the energy required is like going down. That is expected, which is good. And also we see the weekly trends as well. So I think most people are using the hot water heater to do various tasks, like maybe washing clothes or doing dishes and taking showers and stuff on the weekends more. is what we see from the weekly plot. And then also from this plot, we can see that people tend to do more stuff in evenings rather than in the mornings. That's what we can get from this plot. And then we were also curious to see if there is an actual weekday usage differences between a weekday versus weekend. You can see that from these two plots that during the weekday, there is more usage in the morning and also in the evening, whereas in the weekends, maybe people are trying to, they're sleeping in. That's why we didn't see that peak here, but the peak is more around like 10. So yeah, you can understand a lot about people's behavior just from their water heater data. That's what was interesting. And also we decided to, since it's so easy to predict, we created a model for each of the users and then did clustering based on the weekday and weekend usage profiles. And if we were to like model from the source data, it would be super complicated because there are a lot of time points. But if we fit a model, a profit model for each user, and then extract these kinds of curves for each user, and then applied Euclidean k-means clusters, we can divide them into 3 different clusters, which are very clearly defined, or like it clustered fairly well, we would say. So the people who use the water heater on the evenings more will form into one cluster, and the morning people can form into this cluster, and maybe this cluster is very low number, and then the distribution they're using the water heater like all throughout the day. That's what we can get from this plot. And to adapt this to other use cases, maybe if you want to do customer segmentation and things of that nature, you want to do certain kind of marketing and events like that, you can use the time series segmentation and do the appropriate marketing for those customers. And the same thing we did for the weekends as well. And then in the weekends, we see different pattern and then different clusters. So weekday and weekend behaviors we can understand from the water heater usage. And also, if we also inputted the temperature as a regressor. So this is the actual temperature over time. As we can see, it's like increasing, and this is in degrees Celsius. As the temperature increases, the amount of energy required to heat the water decreases, and we can quantify by this. So similar to what we have shown earlier. So 22 is the mean temperature overall. For every degree increase in temperature, the amount of energy required will go down by 2.2%. So that's what we can get from this table. So that's how you can use Profit for real world use cases, and then get more intuition of the data, and also learn what tweaks you can do to increase the output or like change the dependent variable. And in conclusion, Profit is a simple model, but covers many important use cases, especially business use cases that revolve around weekdays, months, that has yearly and monthly and weekly trends. And simple is good. Profit works robustly and fails in understandable ways. Because we have access to the individual plot components, we can look at them, and if there are weird behaviors, we can change it. You can also regularize some of them by using the Fourier n value by increasing or reducing the waviness of the plots. And it's using curve fitting to fit the model, and that makes it very interpretable. And the parameters allow users to input domain knowledge into the forecasts, like adding special holidays or adding special change points that you know that for sure occurred at any given point of time. You can give all those inputs to the model and use the domain knowledge to make the results better. And finally, here are some of the references that I have used. So Sean is the person who created Profit at Facebook. Here's a link to his website, and he has a really nice Twitter explainer thread. I think in like 10 or 12 tweets, he explains everything that I have discussed so far, and I highly encourage you to read that. And Profit docs are quite helpful. I mean, if you look at them at the very beginning, you can get it's really easy to get lost. But after this talk, if you go back and look at the Profit docs, you can understand a lot of parameters easier. And then there is the creator of Profit also gave a talk, and I pasted that link here. If you want to hear him explain how Profit works, you can definitely check that out. And in the paper that explains how Profit works, that's the link to it. And in the Streamlit dashboard, that's the thing where I played with the parameters. You can click on this link and understand it better. And here is a nice book. If you spend too much time having to go through everything, all the features that you can play with in Profit, you can definitely check this book out. It lays out, I think after you read this book, you'll probably know everything you need to know about time series and Profit for most, for almost like 80% of use cases. You can solve with just the information and examples that are provided in this book. And the demo that I showed you with the DV data, a lot of it is from this book. I made slight changes, but most of it is from this. I'll encourage you to check out all these resources to get better intuition. And that's all I want to have to cover for this intro talk. If you have any questions, feel free to ask. So any questions so far?
Hey, Pradeep, I just wanted to say how much I enjoyed the talk and also got inspired to learn Plotly as well. So thank you.
Oh, thank you so much. It's really difficult to get feedback talking to a computer because I wasn't seeing the screen. I was just staring at the computer and like talking this whole time. But I'm glad that everybody was able to hear. There were no technical difficulties or anything, and you were able to capture. So thank you so much.
I second Mark's comment. That was a really great presentation. I especially think it's interesting and super cool that you're able to leverage, I guess, Facebook technology in a way in order to set up some of these models. So definitely something I'm excited to try it on my own when I get the chance.
Yeah, there are a lot of helpful information out there. And like I showed before, there are exactly 10 lines of code that you need to do in order to get your first baseline model app. So once you get it and you look at it, you want to say, maybe I should tweak this, maybe I should add this reducer parameter, and you can build like that. So it's really fun to play with. And Profit made it super easy with all their functions that you can import to do cross-validation, adding regressors, seasonality, and you can build a pretty complicated model just with those tools.
Pradeep, are you aware of any other projects that Facebook has open sourced like this, or out of curiosity?
Yes, Facebook open source a lot of projects. If you go to their GitHub page,
okay,
they have a lot of projects. I mean, most of them are like software related. So GitHub, Facebook. So these are all the different packages. They are open source. There are a ton of them. And I mean, being in the data science realm, Profit is the thing that that I thought was useful, but they do open source a lot of stuff, and all those projects are here. MySQL 5.6, so they even developed MySQL as well. So they do contribute a decent amount to the open source community, and you can check them out here. Oh, here's Profit. I think this should be the most popular projects that Facebook has done. You can tell that by the number of stars and the forks when compared to the other projects. Yeah.
Hey, Pradeep, I got a question, and you probably already covered it in your presentation, and I just kind of spaced out and missed it. But is a prophecy only good for time series data, or could you use it for any type of data set?
Prophet is designed only to do time series analysis only. You cannot use it for any other thing. I mean, for other things, you can use other libraries. So I think last year when I gave the presentation, I presented on fast AI. So if you're interested in classification, or I think fast AI covers a lot of other things, but not specifically time series. I mean, you can use fast AI to do time series as well, but it uses neural networks, and the Prophet uses this generative additive models, which is much easier to do. It takes less time to train, and you get results really fast. It's especially useful when you're trying to do predictions at scale. Like, let's say you have thousands of customers and you want to monitor each of them. Maybe it can be to do anomaly detection. Oh yeah, so anomaly detection is something you can do. Even though it's a time series, you can do anomaly detection through this method. So you can do two things, right? So the first thing is to predict what's going to happen in future, and also do exploratory data analysis with the data that you have. Instead of predicting the next 1 year or next time period, you can just have a more understanding of your current data itself and segment, like I have shown before for one of the use cases that we did.
Hey, Pradeep, building on top of that, so how far exactly ahead can you accurately do that prediction? I mean, there has to be a limit to it, right?
Right. So, I mean, you can visually see that the uncertainty bands will keep growing if
Mhm.
you predict too far into future.
Mhm.
That's a sign that you should not go that far into future, but just limit to the horizon of how much you want to predict. Given the data you have seen in the past and the variation of the data, that will be a deciding factor of how far you can predict. If the uncertainty intervals are too wide, that means that something went wrong. That's when you should scale back.
Yeah, got it. Thanks.
And also, since it's super easy to do and there's less compute involved, you can always update the model as frequently as you want, because it literally takes seconds to fit a model. So as the data comes in, you can use that to predict the next 1 month or 2 months.
Okay. Yeah, that makes sense. Thanks.
So if there are no questions, I think we should end this presentation. Jacob, do you have anything?
Awesome. Yeah, I just want to thank Pradeep one more time. Thank you so much for an outstanding presentation and great questions from everybody at the end too. I'm loving this kind of follow-up, like intermingling within the user group. That's totally why we're here and doing these things. So thank you guys for your great questions as well.
Actually,
Yeah, I just want
I got one
to.
more really quick about the presentation. I really want to check out some of those links at the end of the PowerPoint. Is that going to be posted on the Meetup site afterwards, or?
Yes, so this presentation, we will share it in the meetup so that you can access them.
Okay,
Yeah.
perfect. Thanks.
Yep.
Yeah, and Pradeep, if you just want to send that presentation to me, so that way I can put it on, or I guess you have permissions too if you want to do it yourself, but we can figure that out afterwards.
Mhm.
But we'll make sure that it's available to all the members of the meetup page, so that way they can view the presentation and access those links directly. But see, like I mentioned at the beginning, just to double check, if anyone has any other presentations that they're giving or attending, any sort of seminars, user groups, related things like that, feel free to unmute yourself and just blurt it out whenever, or post it in the chat too. But just as a reminder, Neudesic, we're always hiring over here. We're actually looking to hire right now. So if you are interested in pursuing a job with us, we are looking, I believe, for data scientists in addition to just general developers for mobile, web, anyone who's got any sort of technical background or skills and abilities. Feel free to contact any of the coordinators of the user group, including myself. I try to respond on Meetup, although I'm a little bit more responsive at my Neudesic email. So try and contact me through one of those two mediums if you are interested. Otherwise, if no one else has anything else that they want to share. Cool, I'll take that as a no. Then yeah, I think we're good to conclude this month's meeting. Thank you guys so much for attending. Keep an eye out for our next meeting, which we'll be posting in a couple of weeks for August. And if you're interested in leading a presentation yourself, please contact me or Pradeep or any of the other co-organizers as well, and we'll be sure to get you booked so that way you can lead your own user group meeting. If you've got a presentation that you've done before or one that you just came up with that you want to share, please talk to one of us so that we can get you set up and have you share that with the rest of the user group. But until then, thank you guys so much. Continue sharing the user group and attending and just asking awesome questions like this evening. And we'll see you next month. Thank you, everybody.
Thanks, Pradeep. Thanks, Jacob.
Bye.